Hi everyone, welcome back to the channel. In this video, we're going to take a detailed look at how to allow mDNS access on Windows 11 so your system can properly participate in local network discovery and respond to .local hostname requests. Multicast DNS plays an important role in many everyday scenarios, such as discovering printers, media devices, development services, and other systems on the same network, especially when a traditional DNS server isn't available. By the end of this video, you'll understand exactly how mDNS functions in Windows 11, how to allow it when you need it, and how to keep full control over local network discovery without compromising your system's security. Before we move on, let's take a moment to explain what mDNS is and why it exists. mDNS, or Multicast DNS, is a way for devices on the same local network to find each other automatically. Instead of asking a regular DNS server, like your router or an internet DNS service, your computer sends a question to all nearby devices at once. This allows devices to discover each other without any manual setup. When mDNS is used, Windows 11 sends messages to a special local network address. On IPv4, this address is 224.0.0.251, and on IPv6, it uses FF02FB, both on UDP port 5353. These messages are link local, meaning they are only visible inside your local network. Other devices on the same network listen for these mDNS messages. If a device matches the requested name or service, it responds directly. This allows devices to find each other automatically without using a traditional DNS server. All of this happens quietly in the background, without any user interaction, and it can occur even when you are not actively using device discovery features. mDNS is commonly used for everyday features like finding printers, smart TVs, media servers, and other nearby devices. It is also closely tied to names that end with .local. The .local domain is a special name used only inside a local network and is not resolved on the internet. When Windows tries to resolve something like printer.local, it uses mDNS to ask other devices on the same network which one owns that name. Windows 11 uses mDNS to make networking simple and automatic. As soon as you connect to a network, your system can discover and communicate with compatible devices without needing IP addresses or manual configuration. By default, mDNS is active and allowed through the Windows Firewall on Windows 11, which means the system can automatically send and respond to multicast DNS traffic on the local network without any manual configuration. To verify this behavior, the first thing we need is the computer name that Windows uses on the network. Click Start, type PowerShell, and select Run as administrator, since creating and modifying firewall rules requires administrative privileges. In the PowerShell window, type hostname and press Enter. This command shows your computer's name, which mDNS advertises on the local network and which we'll use in the next steps to test mDNS resolution. Now, let's verify that mDNS is actually active and allowed by testing it from another computer on the same local network. On the second computer, click Start, type PowerShell, and press Enter. There's no need to run it as administrator for this test. In the PowerShell window, type the Resolve-DNS name followed by the first computer's name with .local at the end and press Enter. If mDNS is active and allowed, the Resolve-DnsName command will return one or more DNS records instead of an error. You'll typically see the name field showing the hostname ending in .local, along with an IP address, usually an IPv4 address, and sometimes an IPv6 address as well. This confirms that the target computer successfully responded to the mDNS query and that multicast DNS resolution is working on the local network. If mDNS is not working or has already been blocked, the command will fail with an error such as DNS name does not exist or no such host is known. Now let's go back to the first computer. Because mDNS is enabled by default on Windows 11, Windows Firewall already includes built-in rules that allow mDNS traffic. These rules permit UDP traffic on port 5353, which is the port mDNS uses for multicast name resolution. To verify this, open PowerShell and run the following command. The command starts with getNet firewall rule, which retrieves all firewall rules configured on the system. The outer where object evaluates each firewall rule returned by getNet firewall rule. The $_ represents one firewall rule at a time. Because firewall rules don't directly expose port information, the rule is first piped into GetNet Firewall port filter to extract its associated port settings. A single firewall rule can have multiple port filters, which is why the output is passed into inner WhereObject for detailed inspection. The inner WhereObject checks the protocol and port conditions. The first condition ensures that only firewall rules using the UDP protocol are evaluated, since mDNS traffic operates exclusively over UDP. The second condition ensures that only rules where port 5353 is specified as the local port are included, meaning the rule applies to mDNS traffic on the local computer. The third condition ensures that only rules where port 5353 is specified as the remote port are included, meaning the rule applies to mDNS traffic coming from or going to another computer on the network. The forEachObject block runs once for each firewall rule that passed the earlier filtering steps. Its purpose is to extract detailed information from each rule and present it in a clean, readable format. Inside the loop, GetNet Firewall port filter, associated net firewall rule $_ retrieves details about the rule's network ports and protocol, showing whether it uses TCP or UDP and which local or remote ports it affects. At the same time, GetNet Firewall address filter, associated net firewall rule $_ returns information about the IP addresses associated with the rule, indicating which local and remote addresses the firewall rule applies to. The PS custom object then creates a structured object for each firewall rule that matches the filter conditions, capturing all relevant information, including display name, direction, profile, protocol, local and remote ports, and local and remote addresses. The display name property shows the name of the firewall rule as it appears in Windows Firewall. The direction property shows whether the rule applies to inbound or outbound traffic, which defines whether the rule controls traffic entering your PC from the network, or leaving your PC to other devices. The profile property specifies the network environment in which the rule is active, such as domain, private, or public. The protocol property specifies the network protocol the rule is controlling, such as TCP or UDP, so you know the type of traffic it affects. The local port property specifies the port number on your own computer that the firewall rule applies to. The remote port property defines the port number on the other computer, remote computer, that the firewall applies to. The local address property indicates the IP address, or range of addresses, on your computer that the firewall rule applies to. The remote address property shows the IP address, or range of addresses, of the other computer that the firewall rule applies to. Format table is used to display output in a table format, organizing data into columns and rows. By adding AutoSize parameter, it automatically adjusts the width of each column to fit the data it contains, making the output easier to read. After typing the command, press enter to run it. Depending on how many firewall rules are present, this may take a few moments, so be patient and let the command finish. Once it completes, you'll see a table listing all firewall rules related to mDNS. After checking the existing mDNS rules, the next step is to disable all of them so we can create our own custom firewall rule without conflicts. The command starts with GetNet Firewall rule, which retrieves all firewall rules currently configured on your Windows system. Next, the command uses WhereObject to filter the rules retrieved by GetNet Firewall rule. Inside this filter, GetNet Firewall port filter is executed for each rule to gather detailed information about which ports and protocols the rule applies to. Another WhereObject is used to further refine the list of firewall rules. At this stage, the command looks specifically for rules that use the UDP protocol, because mDNS traffic always travels over UDP. It also checks whether the local port or the remote port of the rule is set to 5353. After filtering, forEachObject loops through each of these selected rules one by one. Inside the loop, each rule is disabled by running the setNet Firewall rule command with the name parameter. After typing the command, press enter to run it. Depending on how many rules are present, this may take a few moments, so be patient and let the command finish before proceeding to create your own custom rule. Once the existing mDNS rules are disabled, it's time to test again from another computer on the same local network. On the second computer, open PowerShell. In the PowerShell window, type the Resolve-DnsName command followed by the first computer's hostname with the .local suffix, then press enter. If everything is working correctly, the command should no longer return a response from the first computer, confirming that the previous firewall rules were successfully disabled and your system is no longer responding to mDNS requests. Return to the first computer. In the PowerShell window you opened earlier as administrator, we'll now create a custom firewall rule to allow mDNS traffic through. The command starts with newNet firewall rule, which tells Windows PowerShell that we want to create a new firewall rule. Then, we use the display name parameter set to allow incoming mDNS traffic to assign a clear and descriptive name to the firewall rule. Next, we use the direction parameter set to inbound to tell Windows Firewall that this rule applies to traffic coming into your computer. Then we use the action parameter set to allow to tell Windows Firewall to permit traffic that matches this rule. After that we use the profile parameter set to any so the rule applies to all network profiles, including domain, private, and public. Then we use the protocol parameter set to UDP to specify that the rule applies only to UDP traffic. Next we use the local port parameter set to 5353 to specify the local port that the firewall rule applies to. Then we use the remote port parameter set to any to allow traffic coming from any source port on the other computer. After that we use the local address parameter set to any to allow the rule to apply to all IP addresses on this computer. Finally, we use the remote address parameter set to any, which allows incoming mDNS traffic from all IP addresses on other computers on the local network. Now that the rule is created and enabled, incoming mDNS traffic on UDP port 5353 is no longer dependent on the default Windows Firewall rules. Instead, it is explicitly allowed by the custom rule you just created. To verify that this is working, go to the second computer on the same local network and open PowerShell. In the PowerShell window, run the Resolve-DnsName command again using the first computer's hostname followed by .local, then press enter. If the firewall rule is configured correctly, the command will return a result showing the .local hostname along with its corresponding IP address. This confirms that incoming mDNS traffic is now allowed through the firewall. And that's it. You've just learned how to allow mDNS access on Windows 11 using a custom firewall rule and how to test it to make sure everything's working properly. If this video helped you, don't forget to like it and subscribe for more tutorials. Thanks for watching, and I'll see you in the next one.